Hello and welcome to Maths with Jacob. This lesson will focus on standard form. I've had two requests to create this video. One request from America and the other one from Australia. I hope those two people find this video very useful. And if anyone else watches the video, I hope you also find it useful and get something out of it. A special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with it and see how you go. If you would like to subscribe now, please do so here. Otherwise, you can subscribe at the end. Standard form. Standard form is a very convenient and easy way to write very large or very small numbers. Examples of very large numbers are the distances between some planets or the mass of the Earth in kilograms. Examples of very small numbers are the thickness of a human hair in meters or the mass of a grain of sand in kilograms. Format. Numbers written in standard form have a very special format as follows. You have your initial number here, which is, I've designated that number by A. A is a number which is greater than or equal to 1 and less than 10. So whatever number you write here must be greater than or equal to 1 and less than 10. Then you have the number 10 to a certain power. N is a positive integer if the original number is very large, or a negative integer if the original number is very small. Now I've got some examples on the next few slides. Let's go through them and hopefully that'll help with our understanding. Examples. Write the following numbers in standard form. Now I want to start off firstly by saying that there's the decimal point for that number. There it is for that number. And there. And there. So the decimal point for any integer, when you don't actually see the decimal point anywhere, is always at the end. So that'll be our starting point. Now, the question we ask ourselves is, where do I have to move this decimal point and place it so I have a number greater than or equal to 1 and less than 10. And you have to place it between the 6 and the 7, because that gives you 6.7. Then you ask yourself, how many places do I have to move the decimal point back to get it to its original position? 1, 2, 3, 4, 5, 6. So times 10 to the 6th. So this number is in standard form, and it represents the number 6,700,000. Second example. Where do I have to move this decimal point to have a number greater than or equal to 1 and less than 10? Between the 8 and the 3. There's our multiplication sign. How far does the decimal point have to move back? 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So it's 10 to the power of 9. The next one, we move the decimal point all the way back here between the 4 and the 5 to give us 4.52. Now, how far do we have to move it back to get it in its original position? Let's go back without doing any marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's 10 to the power of 14. And the last one, way back here, just after the 7, because that gives us the number 7. Now, let's see how far back we have to go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's 7 times 10 to the power of 16. So this is how you represent very large numbers, and you'll notice all these indices here are positive. Write the following numbers in standard form. Now these numbers are very small. Because they're very small, each of these indices, each index here is negative. So here is the decimal point. Now where do we have to move it to end up with a number greater than or equal to 1 and less than 10? Well, we have to move it back here, because that gives us 8. Now how far do we have to go back to have the decimal point in its original position? 1, 2, 3, 4, 5. So we have to go back 5 places. So it's 8 by 10 to the minus 5. This decimal point moves to here, which gives us 7.4, which is a number greater than or equal to 1 and less than 10. To move the decimal point back to its original position, 1, 2, 3, 4, 5, 6, 7, 8. That's 10 to the minus 8. We move the decimal point here. That gives us, right in there, 5.43, which is greater than or equal to 1 and less than 10. Let's see how far back we have to move. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 to the minus 10. And finally, this decimal point has to be moved into there. That gives us 5.06. To move it back to its original position, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's 10 to the minus 13. So all these numbers are in standard form. They're very small numbers. That's why we have negative indices. And that's how we do standard notation for large numbers and small numbers. I hope you found that useful. Here's a quick quiz to help you. Please check through the video at any time. What is the meaning of the following? Too big to ignore. I think if you look at that carefully, you'll be able to understand that answer. Here are the answers to the quick quiz, and please check through the video at any time. If you enjoyed this video, please subscribe on the next slide, and you will receive a notification as to when the next video is available. Hope to see you next lesson.